Hello, I'm Brian LaBelle at AWWA ACE 2022 in San Antonio, Texas. Got the pleasure of meeting with Greg Scobe, retired engineering manager for water, gas, and wastewater with the City of Palo Alto. Now an industry expert on HDPE consulting. That's what brings you to town here.
Yes.
How long have you been doing this, Greg?
Way too long. I started underground piping in 1982 and polyethylene in 1986.
So an early adopter.
Yes.
When it comes to polyethylene and its utilization in utility applications, what was it about polyethylene that attracted you to it as a material for gas and water and wastewater?
It was gas initially, and it was due to material usage at the time that I started for the city. It was not state of the art, and so I was tasked with bringing polyethylene in a medium density gas system.
In the gas application,
right.
Sure.
We did that for years and years. We're very instrumental in all the original directional drilling trials through GRI and Charles Machine Works. We're very active in things like asset management and GIS. We actually put an antenna on City Hall in 1990 so we could capture within a centimeter everything we put underground, real-time kinetic capture. We were aggressive enough that when the DOT came to see us and expected to see paper files, we were able to pull up a map on the wall and click on the feature and pull up all the related information.
Outstanding.
That was before DIMP, and so DIMP came, Distribution Integrity Management came in just after that.
Okay.
Several years later, I became the engineering manager over water, gas, and wastewater, and during that time period, we had already adopted high-density polyethylene for all of our sewer replacements.
Okay.
We were able to avoid increasing the capacity of our sewer treatment plant by eliminating infiltration into the sewer system.
Yep.
Mainly using pipe bursting. We tried all techniques, but we finally honed in on pipe bursting and using dimensionally correct pipe and not a liner. We had a lot of experiences with liner, but in my opinion, it doesn't leave you with something that you can buy a fitting in the field to go and tap and maintain it. And that was our reluctance on liners. I know there's a lot of good liner systems out there now,
Yeah.
but we went tried and true with polyethylene. That brings us up to about 2008 when so we've got gas polyethylene, we've got wastewater polyethylene. 2008, we started wondering why aren't we using it for water? And all the characteristics, the leak-free performance, the resilience as far as any movement, ground movement. We've got the San Andreas Fault actually transects Palo Alto.
Right.
It's the self-restraining characteristics of the fusion. And we were trying to keep using trenchless technologies to install it, but it becomes extremely challenging in an urban environment when there's not a lot of open corridors out there, and now you're trying to install water size that starts at 8-inch.
Yep.
With gas, there's very little 8-inch. It was all 6 and under. So we were able to thread the needle a lot better with 2-inch than we could with 8-inch. We were still successful with 8-inch, but we found when we got to 12-inch, it was open cut. The contractors would come back and they would actually take a hit to open cut it because it was so expensive to directionally drill it.
So you're a longtime believer in the advantages of HDPE as a material for utility piping systems. What's going on currently? Are there opportunities? Are there challenges? And what are we doing to address some of those things?
Well, it's encouraging with the amount of federal funding that's come through recently for water systems.
Yeah.
That I think it's a time that polyethylene is queued correctly. I mean, there's been material shortages, lead times where polyethylene seems to be enjoying a little bit more market share than previously.
Is there a lot of work going on in standardization and training and things like that to help with the installation, making sure that it's good quality and you really get the benefits of the material when it goes in the ground?
I'm a member of an organization called the Municipal Advisory Board. It is sponsored by the Plastic Pipe Institute, which is a trade organization that all the manufacturers are part of. And one of the nice things about MAB is that it's really not driven by the manufacturers. It's driven by water companies. So we have a lot of water companies throughout the United States that we meet semi-annually, and we try to identify issues HDPE related and address those. And one of the first issues addressed was inconsistent training. So we created training documents, and all this is free. I'll throw a picture for the Municipal Advisory Board.
Sure, please.
It's all available. Go onto the Municipal Advisory Board resources in the Plastic Pipe Institute. There are numerous documents. We have generic electrofusion procedures for up to 12 inch, and then we have a cut 14 inch to 30. We have pipe bursting guidelines. We have specifications for pipe that engineers could easily incorporate into their own construction specifications.
Yeah.
We've got one of the most recent documents we created was for cold weather fusion. So as issues come up, we have some cities that are in far North America versus Miami,
right?
And they have different issues, and we take a polling of all of our user members, they're called, that work for cities annually, and then we prioritize what their issues are, and we pick one and we'll create a document associated with it. One of the recent documents was, okay, it's great, how do you fix it? And that was just a recurring issue for us. And so we created a very simple, non-technical document that's actually a fold out with pictures. You have this problem, this is how you fix it kind of stuff.
Right.
That it was totally intended for field use. That also, it answers the question that if you can't get rid of water, you're going to have to use mechanical. There's no way around it. You cannot have water in the fusion zone.
In the fusion zone.
It just doesn't work, and it's a reality check. I mean, every other material out there relies on mechanical connections.
Right.
And it's, while we would all like to have 100% polyethylene fused, non-corroding piping system, it's not reality.
Yeah.
I mean, occasionally you're going to get in situations where valves don't work, you just can't shut off the water, and you've got to fix it.
Yeah.
I mean, people need water.
We've got products, obviously, when it comes to the pipe and the fittings and the electrofusion machines, we've got that covered, but we also have an excellent repair coupling, mechanical repair coupling, the multi-joint 3000 plus, which is fantastic, and we've just introduced our LOX fitting, which is a ductile iron stab type fitting with integrated restraint. We know that fusion is the go-to initially, but as you mentioned, it's not always possible. And there are some advantages to going with mechanical connections, but you want them to be reliable, but as simple as possible, and to avoid corrosion issues as well.
And have the ability to restrain the movement of the pipe. That's huge.
So with all of your experience, have you had some experience with GF Piping Systems? We are at the GF Piping Systems booth. We're standing in front of an HDPE display for water applications. You've had some experience with our people and our company and our products?
I have. I'm a certified fuser through your organization.
Excellent.
I came back and went through your training, and excellent training center.
Yeah.
George Fisher's a major player in electrofusion and piping.
You bet.
No question. Quality products.
Well, we sure appreciate you taking the time to talk with us and share your vast knowledge. It's a pleasure to meet someone, frankly, that has such a long history with HDPE, because it's new. It's still new for so many people.
It is.
And as an early adopter, it's my pleasure to meet you, and I thank you for your time today.
Thank you.
Thank you, Greg. Take care.